Hey everyone, welcome to our lesson on properties of logarithms. Logarithms are a special operation that holds a lot of different properties that we can count on each time. We're going to go over these properties first and then practice using them to expand, condense expressions, and also solve or evaluate. There are lots of things that you'll see listed out on these screens, lots of properties that we'll go over, that when you're doing a unit of this type, it would be in your best interest to memorize, but you can do it slowly, you can do it one at a time, and that way you can work with them more quickly when you come across them in problems. So the first one we're going to look at is the definition-based property, and that is here, which says log base b of b raised to the mth power is m. And the way we read that is, and the reason why the answer is m, what it is saying is what power could we raise b to get b to the mth? And the answer is m. M would make this statement true. It would make it equal on both sides. So that's how we're going to read something like that we see. So we'll be on the lookout for when the base matches the center term there. All right, another property that you may come across is called the product property. And that states that if you have a log term where there is a product beside the base, you can spread that out. You can expand it into 2 or 3, however many terms are in your product, log terms of that same base and split them apart. So log base b of m times n is going to be the same thing as log base b of m plus log base b of m. In the product property, they are added when you expand the expression. In the quotient property, it is just the opposite. They are subtracted. So when you see that you have a log term and there's a quotient present, you can split that quotient up into an expression with a minus sign. So the top one is before the bottom one. So m over n becomes m minus n. All right, moving along, we're going to see power property on some of these. And that just simply means we can take anything we see as a coefficient out in front of our log expression and move it up as a power. That's helpful when you're trying to move things around, expanding and condensing, or even evaluating sometimes. Change of base property. This one is really cool because it helps us get a numerical answer for our expression. If we need to actually evaluate and get a number answer, and we see that we have log base some number of another number, what we're going to do is we're going to take log of the center term here and divide that by log of the base, and that will give us our answer. And you can just type in that operation in your calculator. Most calculators you'll be using have a log button. You can be on the lookout for that, and you just type it in as you see it. Log A divided by log C, whatever numbers you see sitting there. All right, so it's time to practice. So how can we use our properties to expand? Let's say our instructions are to expand the term that we see, expand the expression. Well, one thing we need to remember is that when we expand, each of our terms that this grows into will have the same base, so they should all have a base of 3. So I'm noticing right here that I see a product of 4 times x, so if you remember the product property, we're going to use addition to expand that. So this is going to become 2 log terms of base 3, one with the 4 and one with the x. So there it is. There's our expansion. How about a quotient? Remember that one needs to be expanded with subtraction. So we will take that same base, log base 5, take our top numerator, minus log base 5 of the denominator. All right, how can we go the other way? How can we condense? Let's say we need to simplify and condense the expression. We're going to use the same rules. Anything we come across, we're going to try to move this into one log term. So we notice that these both have log base 3, so this can be done. When they have the same bases, we can perform those rules. The first thing I want to do here, though, is I'm scanning across number 1 here. I see that there's a coefficient there, and remember that power property Before we start, let's go ahead and move that up as a power so that when we condense, we can carry it with that term. So this is going to become 1 log term of base 3, and I see that it's subtraction, so I know I'm going to be using the quotient property of this over this. Alright, so I'm going to take my first term, whatever's sitting there, whether it's more than one thing, a fraction, an ugly decimal, whatever's there, that's going to be on top, divided by y to the 4th. There we have our condensed expression. Right, let's try it one more time. So scanning across, we see that we have the same situation here. We've got a coefficient that could come up to be a power, and then we can carry it wherever we need to. Both of these are regular log terms. They are common log, a log of base 10. They don't have a base, so I can condense them because they are the same. So I will do that. I will say this is going to be log of, alright, I see a plus sign, so we're going to use the product property. So we're going to take 5 squared multiplied by 3. 5 squared coming from this one, 3 coming from the second term. Alright, as long as you can continue, you want to keep going. So I can do a little bit more with this because I know a value for 5 squared is 25. And I can go ahead and multiply out this product. So this is going to actually become log of 25 times 3, 75. You want to go and make it as simple as possible. The most simplified answer is always the best. Alright, let's continue and say that we are given a log term that we actually need to evaluate, find an answer for. Take this first one here, number 1. Log base 4 of 4 to the 7th. What does that equal? Remember our property, the definition property that we talked about in the opening slide, said that we need to read these this way. What this is saying is 4 raised to what power will give me 4 to the 7th. As long as we make these powers equal, we have a true statement. So the answer here is 7. Anytime you see that, where the base matches the center term, the answer is going to be the power that you see. Alright, this one here does not have that situation. Number 2, log base 8 of 5. What would that equal? How would we go about finding that? Well, this is a case where we could use our change of base formula, and we could actually type in, we would go to our calculator, typing in log of 5 divided by log of 8. Remember, we're just going to split it up into the center term and the base separately. And when you do that, you're going to type it in just like this, and you will get an answer approximately 0.774. Alright, so this is going to conclude our lesson on properties of logarithms.